Joe Rand. I work with KidWind, and today we're here at the USA Science and Engineering Festival building wind turbine blades and testing them in our portable custom wind tunnel. So this thing spits out like 7 meters per second, some howling winds in there, and we had over 1,000, maybe 2,000 students come through today building their own blades with simple materials like corrugated plastic, paper plates, cardboard, cardstock, whatever, cheap, simple materials. They'd cut them up, glue them onto little dowels, end up with something like this, a little rotor that they can put on our small wind turbine here. Then we fire up the tunnel. Again, get the howling wind coming through, get some serious wind. These things would spin up, and then we have data logging equipment. So I don't know if you want to zoom in on what we've got down here, but we have a current probe and a voltage probe connected to my computer over here. And that we're projecting onto the screen to collect real-time data and actually compare different wind turbine blade designs and see which designs were the best. So we had a good 4 hours here. Like I said, probably easily over 1,000 students coming through, doing the experiment in teams, building blades and testing them out. And then the winner came up in, let's see if I can find the total power output for the winner. 13.1 milliwatts was our high score today, so that's pretty good.
Pretty impressive. And what was the average, would you say?
Average was more in the probably like 1 to 2 milliwatt range. We had a lot that, you know, they'd try it, land in 1 to 2 milliwatts, but the winners, the people you see over 10 milliwatts, they spent some time, they tried one design, you know, learned a thing or two, went back, redesigned, you know, tried again, you know, they improved a little bit, then they went back and tested again, so they kept improving it, and by, you know, third or fourth try, they'd get up to 10 or 11 milliwatts.
And in your expert opinion, what was it that set these so far above the rest of the competition? Was it strictly design?
Yeah.
Craftsmanship?
Yeah. Attention to detail? I don't know. Yeah, there's a number of factors, and one thing that we see is the blade pitch that they set their blades at is hugely important. So, you know, we see a lot of blades that come in like this with just a huge gap between the hub and where the blade starts, and then they don't pay that much attention to what angle the blades are at. So the angle of the blades is huge, and then closing up that gap so the blade starts right next to the hub. That tends to be a really good secret. Like I said, the angle is key. The size and shape of the blades. We see a lot of blades that are just way too big and they're really slow. They spin slow. This generator, in order to produce any power, needs to spin at high RPM. So the whole goal is just spin these as fast as possible, and that requires shorter blades, close to the hub, and a low pitch angle.
Can you just say, I'm Joe Rand, and representing KidWind from the US Science and Engineering Festival?
Yeah. I'm Joe Rand, here with KidWind at the USA Science and Engineering Festival.